Hello everyone, and today we're talking about improper integrals, which are integrals with a limit or two bounds that go to infinity. Right? And the way that we write these is we use a limit. So we rewrite our integral using a limit to infinity so that we can actually evaluate it. And a lot of times this makes it actually possible to evaluate it. So let's go through an example. All right, so for our first example, this is very similar to what we already did as a warm-up. We can take the limit as b approaches infinity, because it's my upper bound, from 1 to b of 1 over x dx. Okay, so now I'm going to evaluate my integral. My limit stays the same. Okay, and the integral of 1 over x is natural log of x from 1 to b. And now I go through the first fundamental theorem. So natural log of b minus natural log of 1. Okay, now this is going to be 0, and when I plug in infinity for my limit, I end up getting the natural log of infinity, okay, which is infinity. So I see that this is divergent, meaning that there's no area that's contained here. It's just going to get bigger and bigger and bigger until infinity. Okay, that's what that means, and that's what we actually found in our warm-up. Okay, let's try this one. Now in our warm-up, we found that this one was convergent, and so again, I'm going to rewrite my limit as b approaches infinity from 1 to b of e to the negative x dx. Okay, now we evaluate our integral. It's going to be negative e to the negative x from 1 to b. Right, and we do the first fundamental theorem. So negative e to the negative b, and then plus e to the negative 1, because minus and negative is plus. And so when we evaluate our limit, keep in mind that I have a negative exponent here. So what that really means is I have a fraction. So this is negative 1 over e to the b plus 1 over e. Hey, I have a fraction here. So when I evaluate my limit, I have essentially 1 over e minus 1 over infinity. Now 1 divided by a very, very big number goes to 0. So my final answer is 1 over e, or just e to the negative 1. Right, and that's what we found in our exploration earlier. All right, let's go through another one. Now, same deal here, except this time my bottom bound is negative infinity. So I'm going to rewrite this as the limit as a approaches negative infinity from a to 0. Right? I just use a because it's my bottom bound. You don't have to do that. You can use the same letter always. It doesn't really matter. Of e to the x over 4 dx. Right, now we evaluate our integral. So 4e to the x over 4 from a to 0. And then again, the first fundamental theorem. So I have 4e to the 0 minus 4e to the a over 4. So when I evaluate my limit, I get 4 minus 4e to the negative infinity. Now again, when you have a negative exponent, that means you have a fraction, right? And again, any number divided by a huge number like infinity goes to 0, so I'm just left with 4. All right, and let's practice a rotation. Right, so I am given my function. Well, you can't really see that. I'm given my function e to the negative x, and I am revolving it about the x-axis. Okay, and I'm actually not given any bounds. I'm just given the first quadrant. So I know that my bounds are 0 to infinity, because that's the first quadrant. Okay, that's all the x values in the first quadrant. I'm rotating it about the x-axis, meaning I'm using disk method. So I know I have to have a pi, and I know I have to have an r squared. Okay, now my r in this case is just my function, so e to the negative x. That's it. Now I'm going to rewrite my limit, using a limit, I should say, as b approaches infinity, pi integral 0 to b e to the negative 2x dx. Okay, and I can evaluate. I'm just going to bring my pi out to the very front because it doesn't really matter. Right, and when I evaluate my limit, I end up with negative 1/2 e to the negative 2x from 0 to b. Okay, now I can do my first fundamental theorem. And again, I'm going to take this negative 1/2 totally out. Alright, so these constants that are multiplying in, you can just take those out and multiply them back in later. It doesn't affect anything right now. So I have e to the negative 2b minus e to the 0. Okay, this is 1. And when I plug in infinity and evaluate my limit, again, I have a negative exponent here, which means I have 1 over e to the 2 times infinity, essentially. Again, this goes to 0. I end up with just negative pi over 2 times negative 1, which is just pi over 2. All right, that's it for this. See y'all later.